Hey guys, welcome back from break. We're getting right back into exponential functions, and this is page 20 of your packet. Okay, so page 20 of your packet, and we're going to be finding equations or creating equations basically of exponential functions. So just as a review of what we did before break, exercise 1 gives us the general form. Okay, this is in function notation. That's the same thing as y equals a times b to the x. And before break, we were talking about the a value and the b value. And if you pause the video, maybe you can do this on your own, hopefully. So hopefully you've paused the video and you did this on your own. And we know that the a value is simply the y-intercept. So this is the a value is 5, because anytime we have a y-intercept, we know the x value is 0. So the a value is 5. And the b is the growth factor, which is just growth factor means what we're multiplying it by. And that's what defines an exponential. For every increase in one of the x, the y value shows a multiplication pattern. Okay, so the growth factor here is 3. So we just simply substitute in those numbers. Okay, the y-intercept is 5, which is the a value. The growth factor is 3, and the exponent is x, which also defines a exponential. Okay, I know I went through that really quick, but this should be review at this point. And I'm just going to type in the, I thought I could type a text box, which I don't see it there. So I guess I'll just write it. Okay, so basically the a value is the y-intercept. Okay, so when we have a y-intercept, we know the x value is 0. So in this case, we just looked on the table to find 0, 5. And the b is the growth factor. And remember, the word factor, I've said this many times, implies multiplication. So it's just what you're multiplying by each time. And again, since this growth factor is greater than 1, we're going to have exponential growth, and our graph would look something like this. So this is a times 3 pattern. Therefore, the b is equal to 3. And actually, I should add here the a is equal to 5. And then we just substitute into our general form, the y equals a b to the x. I'll write that over here as well. So we put the y-intercept first, and then the growth factor is the base of the exponent, which is a variable. All right, so that's just a quick review of exponential functions. Okay, so now it says finding exponential equations is much more challenging if we're not increasing by unit values. Okay, this is what we're talking about if the x is not going up by 1. All right, so they want us to find this exponential function or equation if we know f of 0 is 8 and f of 3 is 1,000. Okay, so and f of 0 is 8. This is just function notation. They're saying when the input or the x value is 0, then the y value is 8. Okay, same thing with f of 3 equals 1,000. They're saying 3 is the input, and if you were to substitute 3 in for your input, you get 1,000 as your output. So they're just giving us 2 coordinates in function notation. All right, so if we were to write these in a table, okay, 0, 8, and then 3, 1,000, we can't simply divide the y values to get the growth factor because this is going up by 3. So it's in the first table, we have to make sure if we're going to find the growth factor, it has to be increasing by 1. So there's another method we could use. And we're actually going to use, eventually we're going to use systems of equations. So this says use the fact that f of 0 is 8 to determine the value of a. Well, we know when x equals 0, y equals 8. Okay. And we have this equation. All right. So this f of x is the same thing as the output. It's the y value. So I'm going to put 8 equals All right. Now, since this is a special coordinate, right? This is the 0, 8. Hopefully you maybe realize that since this is the y-intercept, that means A is also 8. Okay. And then our growth factor is unknown, and our x value is 0. All right, so really, we could just say, okay, A is 8 because of our knowledge of exponential functions, but we could also follow through with this, okay, to determine the value of A. So actually, I should have just left this as A. My bad. Apologize for that, because we were solving for A. So if I were to solve for A this way, A would be our unknown, and anything to the 0 power, okay, hopefully you know is 1. So this is 1 times A, which is just same as A, and A equals 8. So with substitution or just knowing it's our y-intercept, either way, it comes out that A is equal to 8. All right, so now it says use the answer from part A. We know the A value now is 8. Okay, and it wants us to use this information. So again, when x equals 3, y or f of x equals 1,000, and we're going to substitute it into an equation to solve for b, because now b is our only unknown. All right, we have our x value, we have our y value, or we can write it as f of x value, and then we have our a value. So the only missing variable is b, therefore we can solve for b since it's the only variable. All right, so I'm going to write it out as f of x equals ab to the x. And we don't have to put b in parentheses because we would do exponents first, but you can put b in parentheses if you'd like. All right, so I'm just substitute all my knowns. So f of x, we can see here is 1,000. My a value, okay, since they gave us the y-intercept, we know the a value is 8. And our b value we're solving for, and our x, or our exponent in this case, is 3, because we're just substituting all of these values. All right, so now we're just solving here. And I know when I solve exponential, if I'm solving with the next one, I first want to undo the multiplication. So I'm going to divide by 8. Okay, so 1,000 divided by 8 does not come out nicely. I'm just going to leave it as a fraction for now. 1,000 over 8 and equals b cubed. Okay, so there's a couple different ways we can solve for this. I can say, oh, I want my b value to have a power of 1. Okay, we did this when we were solving before with fractional exponents. I just want to use the reciprocal. So I'm going to multiply by 1/3, since 1/3 times 3 is b to the first power. And when I have a power to a power, I'm going to multiply these two exponents. But if I took this side to the 1/3 power, I also have to take this side to the 1/3 power. Okay, and by now, hopefully you recognize 1/3 power is just taking the square root. So since I'm taking the square root of a fraction, I can take I'm going to say cubed root. I can take the cubed root of each, the denominator and the numerator and denominator separately. Okay, so the 1/3 power is the cubed root. So I'm just taking the cubed root of this fraction, and the cubed root of 1,000 is 10, because 10 times 10 is 100. If I multiply it by another 10, I get 1,000. And the cubed root of 8 is 2. So 10 divided by 2 is 5. So b equals 5 in this case. Okay, so now what I could do is I could write my equation. I have my a value from part A, I have my b value from part B, and I could write the equation y equals 8, or f of x I could write. My b value is 5, and I'm going to keep this as x now. And I could substitute my values to make sure this works. So if I substitute a 0 in for x, I'd get 5 to the 0 power, which is 1, times 8 is 8, so this checks. And I could also substitute my 3 in for x to get the 1,000. So I could say 5 to the 3rd power, which is 125, multiplied times 8, 125 times 8 is 1,000, and that checks. So I know that this equation is valid because if I substitute my ordered pairs that will work in this equation. I can also just graph this and check the table. Okay, check the points and make sure those 2 points are on my graph. Okay, we're going to skip exercise 3 for now, and exercise 4, we'll do that in next lesson. We're going on to, we're going to jump to page 23. Okay. So this says explain the difference between linear and exponential growth. Without writing down any formulas, describe how linear and exponential functions progress differently from one value to the next. Okay, so basically a linear function, linear, for every increase in x, for every unit increase, that means for every x value that goes up 1, there is an adding or subtracting pattern in the y's. Okay, so for every unit increase, unit means plus 1, increase for x, okay, there is and the number that you add or subtract is called the common difference. They're the same distance apart. It's called the common difference. Between the y values. Okay, so common difference means basically there's an adding or subtracting pattern. So common difference, that's a vocab term that you should know eventually. That's for linear. Okay, so for exponential, okay, we're still going to deal with for every unit increase. In x, okay, there is a multiplication pattern. There is a, and we call this a common ratio. Okay, a ratio is a comparison of two numbers, and when we say common ratio, if we divided any consecutive y values, that number would be the same. Okay, and we can say multiplication or division. I'm just going to leave it as multiplication pattern because we can always write division as multiplication by a fraction. Okay, so it's basically the pattern and the y values for every x increase in x. All right, also a linear function looks different. Okay, I know it said without writing formulas or anything, just writing, but a linear is going to be a line. Okay, it has the same slope. Exponential, if your exponential growth, is going to be a J curve. So those are a big difference as well. And that multiplication is what causes it to increase so quickly. All right, for number 2, you're going to do part A for homework. Okay, part B we're going to do together. And it says for each of the following coordinate pairs, find the equation of the exponential function in the form y equals ab to the x that passes through the pair. Show the work that you used to arrive at your answer. Well, for today's lesson, they're going to give us the y-intercept. So hopefully you notice that x is equal to 0. So they're actually giving us the y-intercept. Okay, so we're going to start out with, since it's exponential, we're going to use the form y equals ab to the x. And we know, since we know that a has to be the y-intercept, that our a value for this one is 180. All right, so we're going to use our a value of 180, and then we're going to use the other coordinate they give us as an xy pair to substitute into our equation. Okay, so what this does for us, okay, we have our a value here, we have our x and our y, and it only leaves us with one unknown variable, which allows us to solve for that b value. Okay, so we're going to substitute 80 in for y. Okay, we know our a value is 180. Okay, the b value is what we're solving for, and our x value is 2. Okay, so now we just have to solve this, and we're going to solve for b. So first we need to get rid of this multiplication of 180, which we're going to divide. Okay, and a lot of these are not going to come out evenly. So instead of trying to divide, I'm just going to reduce. Okay, 80, that would give me 40 over 90, which would reduce to 4/9 equals b squared. Now, we could just take each of these to the 1/2 power, but that's also the same as taking the square root. So for this one, I'm just going to get rid of the square, I'm basically doing the square root of both sides. And the square root of b squared is just b. To get the square root of 4/9, I can separate these. Okay, and I'm not going to leave it like that because 4 and 9 are both perfect squares, so b is going to be equal to 2/3. All right, and we prefer to leave it in fraction form. All right, so my equation then, because now I have to write my equation, is y equals 180. Okay, my growth factor is 2/3. Oops. So this is going to be actually decay since my growth factor is less than 1 to the x power. All right, so just so you can see, this is my equation. I have my x, y. These are the 2 points. So if I substitute in a 0 for x, I'm just going to do a quick check this way. Like I said, you could graph it and check these points as well. But if I substitute a 0 here, 2/3 to the 0, anything to the 0 power is 1. And 180 times 1 is 180. So that one checks. All right, if I substitute 2 in, I have 180 times 2/3 to the 2nd power. And I have to do exponents first. So that's going to be the same as 180 times 2/3 squared is going to be 4/9. Okay, and if I'm multiplying with fractions, I can reduce the 180 over 9. I know that 9 goes into 180 because since 9 goes into 18 twice, 9 goes into 180 20 times, and then I can do my 20 times 4, which is 80. And that's a check for the second coordinate. And as long as both of those coordinates are on there, that's a check. You can't just check one value, you have to check both, okay, to make sure it's an exponential. If we just check the y-intercept, like 0, 180, you can have many j-curves that go through that y-intercept. That's why you have to check both of these. Check both of them, or otherwise it's not a valid check. Okay, so for this lesson, they're going to give you the y-intercepts, and we're just going to substitute to find the b, and then substitute a and b for our equation. So the next one that does that, actually, we're going to talk about number 6 too. This one's a little bit different, but it's along those lines. All right, number 6, there's 2 ways to do it, okay? In our next lesson, we're going to talk about how to do this using any 2 of these coordinates. But it says determine whether the function whose tables in this table could be exponential, explain and find the formula. So basically, we're going to find the formula and explain what we're doing. And we're going to assume it's exponential. All right, so this is a little difficult because they don't give us the y-intercept, right? The lowest x value is 1. So if we want to, we have to, I'm going to add another column here. I know the x and f of x are generally first, but if we want to find the a value, then we need to figure out the pattern and go back to 0, okay? Because this would be our a value. Whatever value is here, this would be our a value that has an x value of 0, the y value that goes with the x value of 0. So we need to find that, and we also need to find our growth factor. So our growth factor can only be found if we have consecutive values of x, okay? So actually our growth factor could be found here because 1 and 2 go up by 1, so we could find it here in this section using these 2 coordinates, okay? 2 and 4 are 2 apart, okay? We could find it with 4 and 5 because that's a +1, so we could use these 2 coordinates to find our growth factor. Okay, we could not use 5 and 8 because they're more than 1 apart, but we could also use these 2 coordinates to find our growth factor since we have consecutive numbers. Okay, consecutive just means back to back. Okay, there's only 1 apart. So if I want to find my growth factor, I can take any, I'm going to choose to use 4 and 5. Okay, I'm going to choose to use 4 and 5. I can take any y value and divide by the previous y value, okay, the one before it. So the growth factor, I could take 16 and divide it by 64. I know you may be thinking why not divide 64 by 16? But if you notice, our y values are getting smaller, so we have exponential decay, and we have to divide in this order in order to get our fraction to be smaller than 1. which we should expect for our b value. So you have to take any consecutive x values matching y values and take the latter one and divide it by the previous one. Okay, I know that 16 divided by 64 is 1/4. Okay, I might want to test it for the others. Okay, so I could make sure that this is consistent if I take 1024 and divide it by 4096. And if you calculate this, this also gives you 1/4. Okay, the same with these decimals. If you were to divide these, again, we'd have to take the latter one, latter, ladder, and divide by the previous one. And this will also give us 1/4. All right, so we know that our b value, can safely say that our b value is consistently coming out as 1/4. Now we just need to use those clues to find our y-intercept. All right, so if you think about it, we have to go backward. So if we're going in this direction, we're going to multiply by 1/4, okay? Or another way of saying this is saying divide by 4. So if we want to go in the opposite direction, okay, if we want to go in this direction, we're going to multiply by 4. Okay, 1024 times 4 is 4096. And since 0 and 1 are consecutive numbers, I can find my a value by just doing 4096 times 4. Okay, it's going to be a big number. Oops. But that is the correct b value. So if I calculate this, I'm going to get 6,384. Okay, so my a value is 16,384. My b value is 1/4. So now I can write my exponential equation that goes to this table. 16,384. 1/4, or you can write 0.25 if you wish. Okay, you can write the growth factor as a decimal or a fraction if necessary, and that's my final answer. And again, you can always check these. I could graph it, I could check all my points and verify that that's the answer. All right. Okay, a couple more. So number 9 and 10. Okay, numbers 9 and 10. Oopsie. These are homework. Okay, these are homework. 9 and 10. And notice they give you the y-intercept, so these should be fairly easy. And I'm going to do one in this fashion with you. I'm going to do number 12 with you. Okay, I'm going to do 12 with notes because this is set up as a graph, which is a little bit different. Okay, it doesn't matter how they give you the 2 points, as long as they give you the 2 points. And in this lesson, like I said, they're giving us the y-intercepts because we have the coordinate that has the x value of 0. So we know our a value is 1.2, and we use the other coordinate for our xy, and our only variable left is b. Okay, so we have our y equals ab to the x. We know our y value is 4.8. We know our a value is 1.2. We're solving for b, and our x value is 2 when the y value is 4.8. So we're just substituting and solving. So the first thing we're going to do is get rid of the 1.2 by dividing, because it's being multiplied on the other side. And 4.8 divided by 1.2 is 4. And then we have b squared equals 4. We're going to take the square root of each side to solve, and b equals 2. So our equation is y equals 1.2 for our a value. Our growth factor is 2, and that's to the x power. So again, you could substitute. If you substitute 0 in for your x, you just get 1.2 times 0, which is a check. And if you substitute your 4.8, I should write that down. So 1.2 equals 1.2 times 2 to the 0. That one checks. And if you did 4.8 equals 1.2 times 2 squared, the 2 squared is just 4. And then 1.2 times 4 is 4.8. Both of these check. All right, so your homework, just to reiterate, is to do numbers 9 and 10. And then if you didn't pause the video and do that previous one, the one that we skipped, it's way back. Oops, I missed it. Where is that? Oh, right here, 2a. Okay, so you have 3 problems to do on your own. Have fun. Make sure you check your answers, and you know where to find me for help. All right.